Welcome, everybody. Appreciate you coming to the TRX webinar on this Thursday afternoon. And we will be having our member new as of last year, I believe, Snowbird Technologies presenting. A few housekeeping items for everybody as we get started. We've got a general setup of this to go for about 30 to 40 minutes of presentation time, depending on, Caroline, Scott, and Zach, how you guys feel about Q&A and things like that. Feel free to put your questions in the chat. And there's also a Q&A function in Microsoft Teams that you can use. Both of those are open to you to submit questions during the presentation. Caroline, Zach, Scott, if you guys have any preference to people, raising their hand or coming off mute and interrupting, some people are very fond of that, some people are not. But with that, I'm going to hand it over to Caroline, and I'll let you guys go ahead and get started.
Thank you. Well, good afternoon. Like Zane mentioned, we are Snowbird Technologies. We're a Florida original equipment manufacturer with a focus on defense equipment manufacturing. Today, we do have Scott Morse, our owner and chief executive, Zach Wilson, our project engineering manager and 3D print specialist, and then I'm Caroline Samsel, the marketing director at Snowbird. So our presentation today highlights technologies that foster production at the point of need and how Snowbird Technologies is pioneering expeditionary manufacturing specifically. So the first few slides, we just want to touch on who Snowbird Technologies is in case you have not heard of the company before, and just give a brief background of our history and how we started. This slide is just our mission, vision, and value statement. And ultimately what we like to echo through all of these is a shared theme of protecting and sustaining people and critical equipment in extreme environments and austere locations. And as we dive into who Snowbird is and what we actually produce, this will make a little bit more sense. So Snowbird Technologies, like we mentioned, is based in Florida. Our headquarters and manufacturing facility is in Jacksonville, so Northeast Florida. We do all of the designing, procuring, assembling, testing, engineering, all in this one location. We are a small team, we are a small business, qualified, but we have complete in-house capabilities. We were founded in 1992, so with more than 33 years of experience, we are recognized and trusted as a manufacturer for the defense space. We do brand and market under 3 distinct subsidiaries, and each of these has entire comprehensive portfolio of equipment. Snowbird Environmental, which is going to be our environmental control units, Snowbird Water Technologies, which are our atmospheric water generators, and then Snowbird Additive Mobile Manufacturing Technologies, which will be the focus for today. This obviously is our additive manufacturing product line and the systems that we build underneath that brand. We are ISO certified, and we entered the additive market. It is a newer market for us. We entered it in 2023 with the release of the SAMM Tech product offering, which we'll dive into in the next few slides. So our facility, again, here in Jacksonville, we're equipped to build all 3 of these product lines and can provide support from engineering, administration, business development, procurement, shipping, and receiving. So again, all in-house, all in one location. This is just a really brief overview of the timeline of Snowbird Technologies. Of course, a lot has happened over the past 33 years, but our business is built on a legacy environmental control unit product line, and this is really kind of the core product line. The business is built out on, trusted by Department of Defense and prime contractors. We'll go over a list of just who we've provided for currently and in the past for that, but that gives us a really established presence in the defense market. We diversified the product offering away from just environmental control units in 2021, and then in 2022 with the development of our atmospheric water generator lines, and then our SAMM Tech, the additive manufacturing product lines. Within 1 year of introducing our additive manufacturing portfolio to the market, it was already field testing and demonstrating its capabilities with the Naval Postgraduate School's Consortium for Advanced Manufacturing Research and Education. So it was very quickly brought into the market and brought in for field testing and demonstrations. And that today, regarding the additive manufacturing side, we do, of course, offer a comprehensive portfolio, and we're also working several awarded SBIR funds to continue ongoing development for that system. This is just a snapshot of some of our current and historical clients. Many of those shown reflect our tenure and success with our ECU product line. However, we've also built systems outside of the ECU line for organizations including the DLA, DARPA, Department of the Navy, and the Army Corps of Engineers. And then relying on our company's successful history and knowledge, we're really focused on entrance into the defense market with our newer products, with the AWGs and the additive manufacturing portfolio. It's a space we're comfortable in, and we have an established network. However, commercial opportunities, of course, are increasing. In industries such as energy, so oil, gas, and mining, we see is really the next step into the commercial market. The barrier to entrance there is really just a slower adoption of new technologies. But this gives you just an overview of where we're looking at with the offering that we're going to show you today. And then this is just a snapshot of our professional memberships, of course, like America Makes. It's important for us to be a part of industry organizations to help us establish the business, create valuable connections, and then continue to evolve our product offerings to fill gaps. We learn a lot by being a part of these organizations. We meet a lot of clients and vendors, so it's important for us to have these network capabilities. It's also a great place for thought leadership, opportunities like this, educating various industries and decision makers on what technology is available and the evolving capabilities in the industry. And as Zane mentioned, this is year 2 for us in America Makes, so we're happy and proud to be a part of this team. So again, just our 3 product lines, just to show you a brief overview. The focus today is going to be that third one, Snowbird Additive Mobile Manufacturing Technology, which we call for short SAMM Tech, SAMM-TECH. And so this is a modular containerized manufacturing system that enables on-demand production of critical parts and tools in the field. And again, the focus here is going to be for defense for this presentation. But as you can see, common theme across the portfolio is sustainment solutions at the point of need, primarily for expeditionary operations. So our products are designed specifically for in-field operations. So diving into SAMM Tech and how Snowbird Technologies came about to enter this market and develop this product and this system. Since 2020, the state of traditional supply chains has declined due to a range of factors we all felt, including raw material shortages, workforce challenges, tariffs, geopolitical events. And a common occurrence in defense operations also involves obsolete parts, where the OEMs are no longer a business, are no longer on contract, or just no longer support the parts being manufactured. In austere environments, it's common for warfighters in these situations to cannibalize parts from other pieces of equipment to repair whatever they deem more critical at the moment. And so this is only compounding the problem at the end of the day. So on-demand manufacturing is really the solution that needs to be brought to the table to minimize downtime by keeping the equipment mission capable without waiting for these external sources or factors that sometimes can take weeks to months until they finally get into the hands of the users. On-demand manufacturing allows for customization and prototyping in the field. To meet specific needs at the time. So you're not having to rely on sending out requests to receive molds or have R&D done to have prototype parts created and things like that. This system that we've configured, you're able to actually prototype in the field with 3D printing, CNC machining, and the 3D scanning technologies. And then all of this really reduces your storage and your transport needs. So you're no longer having to bring all of the parts that you think you may need with you out into the field. Not only is that reducing the cost and generating resource efficiency, but it's also aiding in low visibility and clandestine operations, which typically are very important in the expeditionary setting. So we really see this challenge, the solution, to be a force multiplier for defense operations. So the solution, as you've really probably started to see across the board, is this factory in a box idea. And SAMM Tech, the system that we produce, is purpose-built for truly expeditionary production. It's kind of what we touched on in the beginning, just talking about our product lines and our history. We know how to make truly expeditionary equipment. So what we like to note is that this isn't just taking systems that were originally designed for lab use or use in a controlled setting and putting them in a container and strapping them down. That's not what we do. These systems are specifically for that rugged tactical use in harsh conditions, remote locations, and it's all about starting with the container structure itself. So the factory in a box solution, obviously, it's all about bringing production closer to the user. So this brings us into SAMM Tech itself. So this is what Snowbird Technologies has developed to fill this product gap. Again, Snowbird Additive Mobile Manufacturing Technology, a lot of words, we call it SAMM Tech. Our configuration is patented. It's a one-of-a-kind with a robust gantry system that is actually built into the structure of the container. So again, we're not just putting a unit, a printer in and giving it support, strapping it to the walls. We're actually building into the structure of the container to give it the additional support and rigidity for use in the field, as well as while in motion. So our standard offerings right now, everything we've made has been in the 10-foot Connex containers. However, we can build and configure systems into 10, 20, or 40-foot containers, as well as specialty sizes like the ISU 90s. So there really is no limitation on what we can configure. Of course, size is going to determine some of your components and, of course, the part sizes that you're able to make. But the configurations are available in a multitude of container sizes. What's really important about SAMM Tech is that you can operate this as a single container system. So what we mean by that, scalable from forward line of troops to theater level logistics. Each container itself is a complete end-to-end manufacturing factory. We are hybrid manufacturing as well as multi-material manufacturing. So you can do your 3D printing, your CNC machining, 3D scanning, even all in this one singular container. So if that's all you need in the field, you can start with one, or you can scale up, add additional containers to increase your manufacturing capacity. However, each system is a complete end-to-end factory on its own. We'll dive a little bit more into the additive technology that we use and why we use it, but ultimately it reduces the need for additional pieces of equipment as well for post-processing, heat treatment, things like that. So again, it's an end-to-end complete system in this singular container. And we talked about multi-material. So we currently are able to do metals, stainless, milds, tool steel, titanium, Inconel, and some kinds of aluminum, and then plastics as well in this system. So these are mounted onto that gantry system. And so we can do head changes to bring on the capability that you need to complete the part. And then our preferred technologies currently in our standard systems include Meltio, laser wire, directed energy deposition for our metal printing. We are using the Mosquito Prime fused filament extruder from Slice Engineering for our composites in this system. And then we partner with Creaform to allow for 3D scanning, which is great for reverse engineering as well as quality assurance. This is just a snapshot of what the container actually looks like. So this is one container. We're showing here the shipping container exterior, again, laying the foundation for that protective exterior from the elements for transport, operations in harsh environments. And we've got a case study in a couple more slides where we were able to kind of prove the durability of this system in extreme environments. The print bed image, this is one side of the container, double doors open to the print bed. And you can see there that rigid gantry system that's built into the structure of the container. This allows us to produce on unlevel terrain as well as in motion. And then that third image is our operator station. This offers access to all of our systems. You can see there Meltio, engine and user monitors, your FANUC system controls, water chiller, air compressor, electrical panel. We have our gas storage and placement, and then your raw material spools for your weld wire and your plastic filament as well. So operational advantages and mission impact. Obviously, it's all about being expeditionary ready and ruggedized. We've hit on this several times, being modular, being robust for these extreme remote environments. The other side of this, being in a container, it's globally deployable. So right now, it can move through any of the existing logistics infrastructures, just like any other mill van or shipping container can. And of course, operating at the tactical edge or in theater. Supply chain disruption and resilience. Again, we're manufacturing critical parts, obsolete parts, and legacy parts at the point of need. Field ready flexibility. This is all about rapid on-demand prototyping and production capability. So we're boosting efficiency, we're boosting resiliency and autonomy, all in the field, all in the warfighter's hands. I'm going to leave this slide to Zach now, who's going to talk about some of the proven technologies that we've used in this system and why.
Hello. So one of the systems that we use, the primary system that we use is the Meltio DED system. It's a laser and weld wire fed system. So it uses standard weld wire that anyone can get off the shelf, which makes it really easy for people to source material for when out on the field. It's also very good at making parts that are already near their base metal requirements without needing any additional post-heat treating, which is perfect for expeditionary resources. It's also very clean and relatively safe compared to other systems. And the major difference is also the military refuses to use powders out on certain systems due to explosive concerns. So the Meltio was the best choice for our current system. As for the plastic, we can use again standard plastics, and the plastic system can handle extra large filaments as well, and the higher engineering materials. We can go up to some of the composites like the glass-filled nylon or carbon-filled nylon as well, and we can make quick parts out in the field with that. We've also integrated a subtractive system, so it's a router spindle that is designed to be able to cut the hardened steels that we can print with the Meltio. We also have a version that is a +2 axis, so we can do 5-axis machining. Also not pictured on the slide is a diamond wire saw that we also implement to remove parts off of the plate. So when you print a metal part, you can easily get it removed once you're done machining it, so the part can go right into your system. So everything is all contained. Okay. Yeah, so like I was saying earlier, using the laser DED, we can avoid using sintering processes and still know that we have a a good material that's near rot properties. The only real consumables other than the weld wire for the DED system is an inert gas, so either argon or nitrogen, depending on the material, which a nitrogen generator can also be supplied, and some Meltio tips. Just like any other MIG welder, tips start to deteriorate, so you have to swap those out. Other than that, there's very few consumables. As for the plastic advantage, that allows you to make really quick parts. Using the filament fed instead of the pellet fed, we can avoid needing huge dryers and additional air systems for the large pellets and the storage of the large pellets. So using the large diameter filament fed, we can get a better range of systems. Okay. Our system, we have a laser rated protections. The entire system has emergency stops for any kind of well, it has emergency stops for if a person were to touch the door when they're not supposed to. It also has multiple different forms of air control and our ventilation systems. We have the different filtration systems. We have a HEPA filter to take care of all the fumes and off-gassing from the plastic printing as well as the metal printing. And yeah, I think that's pretty much it for that side. Yeah, so for the case study, what we did was we partnered with the Naval Postgraduate School. They wanted a system that they could test both at sea and at their facility. A lot of the systems, like I said earlier, they can't take onto these boats because they're powdered-based systems. But our system was allowed to go onto the ship. So we trained a group of graduate students for about 2 weeks on how to use our machine, and we had them install our machine on the deck. They pretty much just picked it up with their standard equipment, put it on the boat deck, and while we were out there, they were testing sample parts that they had prepared for this mission. So during this mission, we were essentially told that if anyone had any problems or any parts that needed to be replaced, that if they were to stop printing all of their sample parts and make the actual required and needed parts for the ship, while we were on the ship, they had went to replace a reverse osmosis bushing that they had just purchased. This bushing was a 6-month lead time part. It was made out of cast iron. It had recently broke, and they had just got the new one. And when we went out to sea, they went to install it, and they ended up breaking it because they took an impact drill to a cast iron part. So they took this shattered pieces to us, and they asked us to make a new one. So what we did was we printed one out of plastic to fit check it, and So we scanned all the shards and remade the model, and then we made the plastic version to fit check it. Once we knew that our dimensions were all correct, we printed out a stainless steel. Since we knew that the stainless steel was stronger than the cast iron, and we already knew what our material properties for the stainless steel was, we were able to get it, machine it in our machine, and replace that bushing all within about 28 hours. Yeah, so here's more of the machining process and balancing that we did. This was all done by those Marines that we trained. I was out there on the ship with them, but they did everything themselves, and they were able to get this part on, and we were able to keep the mission going without having to turn around or potentially ration water out on the ship.
And then they requested the part stay on the ship actually about a month longer than was originally intended. So it did stay on the ship until it's returned back to Naval Station Hawaii.
Yes.
So broader implications for the DoD and industry, of course, key benefits for defense and industrial applications. This is all about ultimately saving time. As Zach mentioned, the part that they replaced on the ship had a several-month lead time, and there was really no way for that to be replaced at sea and while staying at sea. So saving time in these situations is really the critical piece. A lot of times it can also save money simply based on having to pay for shipping and logistics or purchasing a rush part or a prototype R&D part. So at times you are also able to save money with this system. And then saving space. So like we mentioned earlier, having the system in the field in proximity, you don't necessarily have to bring the authorized stockage lists that are typical for missions because you can print what you need when you need it if you have this system in the field. And of course, all this is about increasing warfighter readiness as well as operational readiness for commercial industries. Like we mentioned, we've worked a little with oil and gas in the commercial market, and those offshore rigs, they were telling us if they had a catastrophic part failure like this, that they lose about $1 million each day. So a system like this would pay for itself and then some if installed in those types of scenarios. So this expeditionary manufacturing is very much in alignment with the DoD's additive manufacturing strategy. We're hearing more and more about the demand for point of need operations because commands are becoming more decentralized. So this is really fitting a niche market for defense. And of course, potential future applications in fleet maintenance as well. So talking about having these systems across DoD networks, across shipyards, as well as in expeditionary settings to really support the parts replacement and repair needs. So the future vision for the technology, like we said, logistics, command are all becoming decentralized and agile. We hear that a little bit about that every day. Point of need manufacturing enables localized part production. And of course, addressing the key issues of part obsolescence and procurement delays ultimately is the most important issue. We see for the future, of course, we hear it a lot. I'm sure anyone in the field hears it a lot about parts or process qualifications and standards. That's still an area that, we are also kind of waiting to see what that process will look like. So we often get questions about part certification and qualifications. If you have any of those today, feel free to put them in the chat and we can try to help address those and how we see the answer to that right now. Software development is also a part of our future vision for our specific product offering, and really just having a dedicated system that can ensure plug and play operations, make it very simple to have these units in the field and operable by operators of various skill levels. So that is our vision for the future of the technology. Of course, DoD, we can already assume will continue to put out more requirements for this technology and what that looks like. And so Snowbird plans to stay at the forefront of that as well. So that's all we have today, but we can open the floor for questions and answers, and hopefully Zach and I and Scott can help answer that.
Fantastic. Thank you. Thank you. All right. So to kick off our Q&A session, I want to welcome anybody that would like to come off mute. Go ahead and open up discussion over voice. Sujit, I see you have a question in the chat. If you wanted to pop off of mute there and go ahead and ask your question. No? All right. Looks like Sujit is not responding here. Larry, if you want to come off chat, mute and ask your question. I see you've got your hand raised there.
Sure thing. Hi, Larry Dickinson with 3F LLC. My question is about composites. You mentioned composites polymers, not just thermoplastic. Are you looking at only chopped filled thermoplastic, or are you looking at continuous fiber? And then what sorts of materials can you use?
Right now it's chopped because that's what the slice nozzle can do. We are looking at different types of continuous fiber. However, that would require a redesign of the actual print nozzle itself, and there's not too many companies that I've been able to source that have that kind of a system that we can implement into ours, which means that we'd probably have to develop our own. So right now, we're not too focused on continuous fiber until there's a few more options out on the market. But if we can locate that, it's something we can add.
Fantastic.
Sure, that makes sense. And just to follow up that question, we're developing a continuous fibril, wholly thermoplastic, self-reinforced continuous fiber feedstock that works in ordinary nozzles. We're not in production yet.
Oh,
but
really?
We're getting close. I just dropped my email in the chat. Let's have some conversation.
Definitely, yeah, that sounds great.
So fantastic. All right. I don't know if Sujit is still on here, but I'll go ahead and ask his question. Oh, there you are. Perfect. I'll let you go ahead.
So my questions were particularly pertaining to, you mentioned titanium and other reactive metals. How exactly are you doing any post-processing? Because without any post-processing, the material integrity of titanium, etc., it is kind of challenging to maintain in the field. If you can elaborate a bit on that, that'll be great.
Yeah, so right now for titanium, a lot of the titanium parts, we have a specific material. Essentially, we tell them what the yield material of the titanium will be direct out of the machine. If someone were to require a more one-to-one for titanium, that they would require an additional heat treating process. However, right now we're not focusing so much on the qualification of highly critical parts like that. It's more of an immediate replacement part. So if you know that your titanium that you're getting out of your printer just needs to be an eighth of an inch thicker based off of our material properties that comes out of the machine, then they can use that and replace their part with that without having to undergo a full heat treating process.
That kind of creates some challenges because it doesn't maintain the structural integrity of especially flight grade materials.
Yeah, we're not doing flight grade at the moment. These
Understood.
are,
Thank you.
yeah.
Great. I actually have a question. I don't see anything else coming up in the chat at the moment, but my question is you know, you guys are still developing the systems and expanding your, I guess, functionality and application space. What would be something that you could ask the rest of membership for assistance in? I know we just had to talk about the material there with Larry, but is there anything else that there's a technology or a particular capability that somebody in the membership might be able to assist with?
Zach has anything specific, I think something important to note is that we are an integrator. So obviously we're not making our own 3D print systems or our own subtractive systems. We are procuring those and creating the configuration so that they can all live within the same system. So basically we're a custom configurator. So if there are technologies out there that a customer is saying, I need expeditionary, but I require this technology instead of Meltio laser wire DED, we are open to putting together configurations that can meet other requirements. So it doesn't have to look exactly like the specs that we presented today. So I guess just kind of if anyone in the membership even has either a customer, a requirement, or even just a technology that they think could live within this system, we are open to discussing, creating product partnerships, trying to figure out where we can place product and create even more customized applications, I guess you could say, for each customer.
Thank you. Yeah, I appreciate that. Always good to know how people can jump in and help.
I also had one more question. How does the system manage the at-sea movements? Does it cause any challenges with regards to making parts using additive manufacturing, because the ship is obviously not stable?
So the way that the container is designed, as long as the gantry itself has been aligned to its bed, it's able to keep itself in line to itself while it's printing and while it's machining. They actually found that with the vibration of the ship and even the rocking of the ship, it actually helped the weld pool from the laser DED system to actually help level out, which gave us even better results out at sea than it did at the facility back in California. So that was another reason why we chose the Meltio as well, is that its head is designed to be able to print at a 90-degree angle. So we weren't too concerned about the actual movement of the ship. So it turned out really well, the whole experiment.
Thank you.
Thank you. All right, we'll continue on with any other additional questions. Not seeing anything come through, and nobody's coming off mute here. Let's see. What are some considerations around materials such as metals versus polymers do you see as most critical for ensuring reliability of parts that are manufactured out in the field?
I'm sorry, what exactly do you mean, like replacement field parts for either metal or plastic, or?
Yeah, are you seeing a higher demand on the metals or the polymer side for field parts?
Yeah,
Field
we're
manufactured
definitely
parts.
we're seeing a lot more for metal parts. That was the whole original reason we built this this version of our machine. The first one was polymer, but the military kept asking for metal. One of the first ones that we made, they actually wanted to use it to make giant locks or gears for water locks, because those were made 50, 60 years ago. No one can cast them anymore, and they're huge. So that was the kind of idea of what we wanted to help replace, and with our system. A lot of the plastic parts, a lot of the customers, or at least the military, they feel like they can get just a bunch of throwaway, um, uh, like desktop printers, essentially, for anything small for polymers. And if they need anything better for polymers, that's when they're looking at like PEEK, where you need those engineering polymers. But that's been even a hassle for them, so they just kind of want to stick to metals.
Gotcha. All right. Well, we'll give it about another minute here, see if anybody else has any additional questions. Yeah, Greg, feel free to come off mute here.
Hi, good afternoon. First of all, thank you very much for the presentation. It's really it's an awesome product that you're offering here. I'm from Parts Life. One of the things we do is reverse engineer obsolete parts, to develop technical data packages, and then be able to manufacture that part to back the way it was originally manufactured. And you had mentioned certification and qualification before, so just curious how that's handled when there, I would assume, may not be a technical data package per se for this additive part. So to what extent can it be reverse engineered? And then can you talk about the qualification and certification process to be able to use that part? Thank you.
Yep. So for right now, what we have is we partner with Creaform. They have a 3D scanning system that can go down to, I think it's 0.0001 inches for their accuracy for all of their parts. So most of what we do is we'll scan that, we'll throw it into their CAD system, modify it if need be. Like if it's a damaged part, we'll fix it in their software, and we can additionally take physical measurements of the part and make sure that that we've completely reverse engineered all of the critical surfaces and even the non-critical surfaces if requested, and we can essentially get it completely remade in the computer. At that point, we can either fit check it with like the plastic printing, like we did before, or we can print it, machine it down, and compare it to the original part. As for part certification, again, that's a lot of what the customer specifically requests. Right now, I've kind of been trying to get the military to certify the printing process, so that they have more of a uniformed idea of, if they print something with this process, that the part that comes out is going to be good. But until they do that, a lot of the certification is after the part is done, it either has to be sent out to a lab to get tested, either destructive or non-destructive, or some other people, they only request a materials test. So we work with, or we're potentially working with some companies that can do in-field material testing for the structural integrity of the parts, and usually that's enough for people to certify the parts. As for the military, like with that bushing, we went to the commander and it was to his discretion to replace the part based off of what we made and showed him. So part certification is a little different between different companies or the military. So that's kind of how we've been handling it at this moment.
I'll just jump in. We're not in the business of making and selling parts. We're in the business of making the system. So obviously we come up with that. We come across that question all the time, and we continue to work on it. But that's really for the user to, determine.
Understand. Thank you. Thank you.
Great. These are fantastic questions. Keep them coming. Does anybody else have anything they want to ask? We'll give it about another minute here. And if nobody hops off mute here, we'll give you a couple minutes back in your day. Sujit, I see
I
you
have one
coming
more
off.
question.
There you go. Yep.
With regards to on-field deployment, what are the challenges in training warfighters on the field in using this specific equipment? And is there any specialized knowledge required? And what is the typical lead time that a person needs to be able to operate this equipment?
Yeah, so that's a good question. The people that we trained them, it took about a week of training for the Creaform scanner and another week to use our machine. It was a relatively short period because they already had the general basic knowledge of CNC processing. So it's really anyone that has basic knowledge of any other CNC like kind of a knowledge. You can still use the system manually. So if you have any knowledge of using manual lathes or subtractive machines, it would only require a little extra training to teach you how to do the additive portion. So, I mean, I would estimate approximately a month for someone that's completely brand new that knows nothing. You can easily get them trained up on the machine well within that time period. And yeah, I think that's pretty much that's probably how much time it would take.
Well, I just add, we are working on a AI-based software package to integrate into the machine for the purpose of making it not idiot-proof, but more user-friendly. So we can reduce the training time, and a soldier in the field with just basic knowledge can operate the equipment.
Thank you.
Yeah, keep the questions coming, guys. This is fantastic. Another minute or so to hop off mute. It seems every time I tend to lead towards the end of the conversation, somebody's got a question. So we'll give it just about another minute here and see if anybody wants to come off mute and ask a final question. No? All right. Well, with that, I want to say thank you to our presenters. We've got Scott, Caroline, and Zach here from Snowbird Technologies. So if there's no more questions, I'd like to wrap up today's TRX webinar. If you have any other questions for the team here, feel free to reach out to them. They've got their email addresses there on the screen at this point as well. So feel free to contact them with any additional questions. And if you'd like to participate in a TRX webinar, please shoot myself an email or go to our site and under membership, please fill out the form about member presentations. If you have any other questions, feel free to come off mute. I'll stay on here for the next couple of minutes, but we'll go ahead and close out the TRX webinar for the rest of for today. So thank you.